Hello, welcome back. Today we are going to solve Leetcode problem 673, number of longest increasing subsequence. So this is similar to the longest increasing subsequence, but just we need to calculate the numbers. So for example, 1, 3, 5, 4, 7. So there are two numbers of longest, which is 4. Yeah, it is similar, but it is much harder. For the longest increasing subsequence, we don't need to check the numbers. We just need to return the longest. For example, this one is 4. We don't need to check if it is this one or that one. Yeah, if we need to check the arrays, for example, we need to return these two arrays. It will be much harder because we have to go backtracking. But for this problem, we just need to count how many of them. So this is similar than that. But it is harder than the longest increasing subsequence problem. Yeah. For my solution, basically, I did it on the base of longest increasing subsequence problem. So this is the template code for the longest increasing subsequence problem. As you can see, I just prepare n is the length of the array, and the dp is 1 times n. Yeah, because for our calculating of the longest increasing subsequence, we're going to prepare a 1, because at least it will have a length of 1 and times n. And here is the template code, and for r in range 1 to n, and for l in range r. Yeah, because I'm going to check from l to r. So for each one of them, I'm going to check the numbers. If it is bigger, nums r bigger than nums l, I'm going to update dp r with max dp r with dpl plus 1. And if we are calculating the longest increasing subsequence, we just need to return, for example, a dp. Yeah, just need to return a max of dp. But here for our problem, we need to count. So I'm going to do some change. Yeah, so actually the change is also easier to understand. First of all, I'm going to prepare a count array. So this count is also a dp array. So for this problem, I'm preparing two dp array at the same time. One dp array is for checking the longest increasing subsequence. Yeah, the longest, it is just a value of the longest. Yeah, it's similar to the longest increasing subsequence problem. Yeah, and for the second one is a count. I'm going to count if, for example, at this place, if the longest is 4 and how many of them. For example, 1, 3, and 4, the longest up to here is 3. I'm also going to count how many of them, but at this place it is 1. But at 7, it is also 1. But sometimes it may be many of them. Yeah, in our example, this is at 7, there's 1. Yeah, at 7 there are 2, because as you can see it, 7 can come in from 4 and can also come in from 5. So there are 2. So this count array is also a dp array for counting how many of them. For example, at this index 4, at this place, so there are 2. So how did I do by that? So initially, I'm preparing the first index with 1, because for my dp array, I'm going to start from 1 first. As you can see, the dpr start from 1. So for the first place, by default, it will be a 1. And for other places, I'm going to prepare it as a 0, because I'm going to count 1 by 1. Yeah. Now, I'm going to check it like this. So similarly, it's also here, but it's 2 paths. This path is for the longest subsequence, is for the longest increasing subsequence. And this part, after recalculating the longest, we're going to count it. How should we count it? Basically, we just need to loop through the L to R, and if this nums R more than nums L, it means we can count. And also, we need another condition. If this dpL equals to dpR minus 1, this means where am I coming from? For example, this 7 can come from this 4 and this 5. So this is why I need to use this method to count it, because I'm not going to check 1. I'm going to check 1 by 1, all of them. If it meets the condition, I'm going to count. As you can see, if it meets the condition like this, dpL equals to dpr minus 1. Why? Because for the first loop, I've already calculated the longest distance. I've already have the DP value. Now I can directly use it. Yeah, I will know where am I coming from because I've already calculated. For example, this is for this DP. So for example, for this DP4, I know where am I coming from. I can come from here and I can come from here. I just needed to count how many of them. And at this place, there's 1. And this 5, there's also another 1. So this is why I use count R plus equal to count L. So I think this is easy to understand. And I also tried some errors and corrected it. Like from the beginning, I prepared the count as always be 1, not 0. After that, I found a mistake and I changed it to 0. Because after that, I have to check my count. So for this one, I've already finished updating of my count R. And I have to check if I updated or not. If not count R, it means if inside it is still 0, I'm going to update my count to 1 because at least it will be 1. It cannot be 0. For example, at this place, the count should be at least 1. It cannot be 0. This is why I will give a count R to 1. After finishing this 5 lines of code, I think it's really easy to understand. We just need to find the maximum value inside the count and count how many of them. So this 4 lines of code is exactly what I said. This is much simpler than that. Yeah. So the max value, max num, is the max DP. It means the longest distance. It is 4. Yeah. For example, this is 4. We just need to count how many of 4s. So we just need to enumerate the DP I and n. If n equal to the maximum of number, we just need to use the result plus equal to this count I. For example, this example, the maximum is 4. Maximum is 4. If this n is here, if this n inside the DP, if the value equal to the maximum inside our DP array, so inside the DP at this position, this value n equal to maximum, it is 4. And the result should plus equal to count I, count 4. So the count 4, what is the count 4? It is 2. Yeah, because up to here, our count array has already been updated. We just need to check the count. I think this is much easier. You should understand that. The hard part, maybe a little bit hard part, is about this area. But the idea is similar to the DP array. And we just have an actual array of count. And for this count, we just need to first finish the DP array and then check where are we coming from. So this is where are we coming from. We should check if this nums R more than this nums L, and also the DP L should equal to DP R minus 1. So yeah, now let me run it to check if it works. As you can see, it works. Now let me submit it to check if it can pass all the testing cases. Yeah, as you can see, it can pass all the testing cases, and the time complexity is still O(n) squared because we didn't increase any time complexity compared with the longest arithmetic subsequence. Yeah, but it's not so fast. Yeah, that is still okay. At least we passed it, and it's a simple method. Now let's check the value of the array. Yeah, so it is 2000 and it should be okay. Thank you for watching. If you think this is helpful, please like and subscribe. I will upload more Leetcode problems like that. See you next time.